In modern strategic competition, a single massive entity is often just a single massive target. To survive and win in this environment, the most advanced systems are designed to divide into many smaller pieces. India's Agni-5 missile represents this strategy in its most physical form. On its own, it's a heavy-duty piece of engineering. It can travel at nearly 30,000 kilometers per hour and reach targets more than 5,000 kilometers away. But its real strength comes from a specific upgrade called MIRV. It stands for Multiple Independently Targetable Reentry Vehicles. It effectively turns a single missile into a delivery system for an entire cluster of separate warheads. Here is how that looks on the inside. This striped nose cone isn't covering one giant explosive. Instead, it houses a group of smaller, miniaturized warheads packed together. By shrinking the payload and multiplying it, a single launch shifts from being a brute force tool into a flexible, multi-target threat. Standard missiles follow a simple, predictable path through the sky. Because their arc is easy to calculate, modern defense shields can track them and shoot them down with a single interceptor. This trajectory map shows how a MIRV system bypasses that. A specialized platform called a post-boost vehicle, or a bus, maneuvers in space. It uses small thrusters to change its position before releasing each warhead one by one. Because the bus adjusts its position between each release, every warhead follows a totally different path. A single missile can now strike multiple cities or installations that are hundreds of kilometers apart. To make things even more difficult for the defense, the vehicle also releases decoys. These are lightweight objects designed to look exactly like real warheads on an enemy's radar. When you combine several real warheads on different paths with a cloud of false targets, the math becomes impossible for a defense system to handle. There are simply too many incoming objects to stop. This creates a situation where an adversary knows they can't physically block a retaliatory strike, which is the core of a credible nuclear deterrent. This move away from a single central target is happening in our digital world, too. Our current internet architecture actually has the same vulnerability as an old missile. It's too centralized. This is Web 2.0. In this model, large tech companies store user data on central servers, like these blue cable bundles. Because everything is stored in one place, it creates a single massive target for hacking and control. Web 3.0 is the digital version of that MIRV upgrade. It's a design built to break up those monopolies and distribute control. The foundational architecture is the blockchain. Instead of a central hub, it redistributes data across thousands of independent global nodes. Since every computer has its own copy, no single company can alter data without everyone noticing. It removes the internet's central target entirely. By getting rid of those central servers, this technology hands digital ownership and privacy back to the individual user. To keep this distributed network running without a central boss, the system uses what are called smart contracts. A smart contract is blockchain code working on simple logic. If you buy a digital asset, the code verifies the funds and the asset. The second both conditions are met, ownership transfers automatically, without a bank or lawyer in the middle. This automation is what makes digital ownership verifiable. It ensures that assets like personal data records or digital property cannot be faked or tampered with by anyone. Users no longer have to worry if a corporation is being honest or if a platform will change its rules. By letting the code enforce the agreement, the system works without requiring any human trust at all. There is a clear parallel here. The way warheads spread across the sky to bypass a shield is exactly how blockchain nodes spread across the internet to bypass a data monopoly. In both cases, a single, slow-moving mass is a liability, but a fluid swarm of independent pieces is almost impossible to stop. Just as only a few nations have mastered MIRV technology, we are now seeing a global race to control the infrastructure of Web 3.0. Security is no longer about who has the biggest center, but who has the most resilient network. Whether it's protecting a barter or a digital identity, moving away from a single central target has become a defining strategy for security. The future belongs to the swarm.